Trigonometric functions are so critical, we've got to develop some rules to differentiate them as well. That's what we're going to do here. Trigonometric function differentiation rules for the big six trigonometric functions. Let's look at the function y equals sine theta. You're familiar with that function from trigonometry. Here's what it looks like from negative pi to pi as input. So an interesting thing happens if we start to calculate the slope at each of these points. If we look at negative pi and the slope there, looks like it's a negative amount. It's negative 1. If we continue on, here's negative pi over 2. Well, looks like the slope is 0 there. It's flat. And at 0, the slope is positive 1 now. And at pi over 2, the slope is back to 0. And finally at pi, the slope is negative 1 again. So if we actually plotted those points, and you can see as it was going along these little light blue dots as we're going along, if we plotted those and made a graph of them, something interesting happens. Well, do you recognize that? I hope so. It's the cosine graph. So what this is telling us is the derivative of the sine function is the cosine function. And that is, in fact, the first identity we'll start with. The derivative of the sine of x with respect to x is the cosine of x. We can do the same thing for cosine. Here's the cosine graph. Plot its points and find the slopes. At negative pi, it's flat. At negative pi over 2, it's 1. At 0, the slope has gone to 0. At pi over 2, the slope is negative 1. Again, we're looking at the slope of the tangent line at that point. And then finally, at pi, the slope has gone to 0 again. So let's connect those dots. Another interesting thing. It's not quite the sine curve. It's the negative of the sine. The derivative of the cosine function, the slope of the tangent line of the cosine function at any given point, is the negative of the sine. So the derivative of cosine x with respect to x is equal to negative sine of x. Now, knowing those derivatives of the sine and cosine opens up the ability to find the derivatives analytically of the other trig functions. So let's find the derivative of the tangent function using the quotient rule. What we're going to do is we're going to take tangent of x and rewrite it as sine over cosine. Because the tangent, as you recall from trigonometry, is equal to the sine divided by the cosine. So the derivative of the sine divided by the cosine with respect to x, we're going to use the quotient rule with the two new identities we have now. Low d high minus high d low over the square of what's below. Well, low is the cosine, high is the sine, so low d high, the derivative of the sine is the cosine, minus high d low over the square of what's below. Okay, and so we have the cosine squared of x plus the sine squared of x over the cosine squared of x. Well, you may recall the cosine squared of x plus the sine squared of x is a Pythagorean identity that gives us 1 over the cosine squared of x, which is also known as the secant squared of x. So therefore, the derivative of the tangent of x with respect to x is equal to the secant squared of x. Using these identities, the derivative of all the 6 trigonometric functions can be determined. The derivative of the cotangent is equal to the negative cosecant squared. The derivative of the secant is equal to the secant times the tangent. The derivative of the cosecant is equal to the negative cosecant times the cotangent. And here it all is. Now you'll notice some patterns here. The derivative of the sine is the cosine. The derivative of the cosine is the negative sine. The derivative of the tangent is the secant squared. The derivative of the cotangent is the negative cosecant squared. The derivative of the secant is secant tangent. The derivative of the cosecant is negative cosecant cotangent. So cofunctions have a negative derivative of their parent function. Let's look at some examples of trigonometric functions. And we're going to combine the trigonometric rules you've just learned with the other rules that we've already learned about differentiation. First, we'll look at y equals 2 sine x. To find the derivative of this function, we're going to use the constant multiple rule. So it'll be 2 times the derivative of sine x So dy dx will be 2 times cosine x, since cosine is the derivative of the sine. Let's look at this next function. F of x equals cosine x over 2. Well, that's again a constant multiple rule. So we're going to kind of split this out as a 1/2 times cosine of x. So the derivative is going to be 1/2 times the derivative of cosine x, which is negative sine of x. In simplified form, negative 1/2 sine of x. Finally, let's look at s of t equals t squared plus tan t. And the derivative of that, we're going to use actually 3 different rules here. We're going to use the power rule on t squared. We're going to use the sum rule to add the derivatives here. And we're going to use the derivative of the tangent, a trigonometric rule. So s prime of t, the derivative of s with respect to t, is equal to the derivative of t squared, which is 2t, plus the derivative of the tangent, which is the secant squared t. So the derivative of s with respect to t in this case is 2t plus the secant squared of t. Plus the secant squared of t. Now you've built the derivatives of trigonometric functions, and you can use these rules to evaluate and differentiate just about any trigonometric function.